With an equatorial diameter of about 120,500 km, Saturn is 9 times wider than Earth. If Earth were the size of a nickel, Saturn would be about as big as a volleyball. From an average distance of 1.4 billion km, Saturn is 9.4 astronomical units away from the Sun. 1 astronomical unit is the distance from the Sun to Earth. From this distance, it takes sunlight 80 minutes to travel from the Sun to Saturn. Saturn has the second shortest day in the solar system. One day on Saturn takes only 10.7 hours, and Saturn makes a complete orbit around the Sun in about 29.4 Earth years. Its axis is tilted by 26.73 degrees with respect to its orbit around the Sun, which is similar to Earth's 23.5 degrees tilt. This means that, like Earth, Saturn experiences seasons. Saturn took shape when the rest of the solar system formed about 4.5 billion years ago, when gravity pulled swirling gas and dust in to become this gas giant. About 4 billion years ago, Saturn settled into its current position in the outer solar system, where it is the sixth planet from the Sun. Like Jupiter, Saturn is mostly made of hydrogen and helium, the same two main components that make up the Sun. As a gas giant, Saturn doesn't have a true surface. The planet is mostly swirling gases and liquids deeper down. While a spacecraft would have nowhere to land on Saturn, it would not be able to fly through unscathed either. The extreme pressure and temperature deep inside the planet would crush, melt, and vaporize any spacecraft trying to fly into the planet. Saturn is blanketed with clouds that appear as faint stripes, jet streams, and storms. The planet is many different shades of yellow, brown, and gray. Wind in the upper atmosphere reach 1,600 feet per second in the equatorial region. In contrast, the strongest hurricane force winds on Earth top out at about 360 feet per second, and the pressure, the same kind you feel when you dive deep underwater, is so powerful it squeezes gas into a liquid. Saturn's North Pole has an interesting atmospheric feature, a six-sided jet stream. This hexagon-shaped pattern was first noticed in image from the Voyager I spacecraft and has been more closely observed by the Cassini spacecraft since. Spanning about 20,000 miles across, the hexagon is a wavy jet stream of 200 mile per hour winds, with a massive rotating storm at the center. There is no weather feature like it anywhere else in the solar system. Saturn rings are thought to be pieces of comets, asteroids, and shattered moons that broke up before they reached the planet, torn apart by Saturn's powerful gravity. They are made of billions of small chunks of ice and rocks coated with other materials such as dust. The ring particles mostly range from tiny, dust-sized icy grains to chunks as big as a house. A few particles are as large as mountains. The rings would look mostly white if you look at them from the cloud tops of Saturn. And interestingly, each ring's orbit at a different speed around the Sun. Saturn's ring system extends up to 175,000 miles from the planet, yet the vertical height is typically about 30 feet in the main rings. named alphabetically in the order they were discovered. The rings are relatively close to each other with the exception of a gap measuring 2,920 miles in the width called the Cassini division that separates rings A and B. The main rings are A, B and C. Rings D, E, F and G are fainter and more recently discovered. Starting at Saturn and moving outward, there is the D ring, C ring, B ring, Cassini division, A ring, F ring, G ring, and finally the E ring. Much farther out, there is the very faint Phoebe ring in the orbit of Saturn moon Phoebe. Saturn's magnetic field is smaller than Jupiter, but still 578 times as powerful as Earth. Saturn, the rings, and many of the satellites lie totally within Saturn's enormous magnetosphere, the region of space in which the behavior of electrically charged particles is influenced more by Saturn's magnetic field than by the solar wind. Aurora occur when charged particles spiral into a planet's atmosphere along magnetic field lines. On Earth, these charged particles come from the solar wind. Cassini showed that at least some of Saturn's auroras are like Jupiter and are largely unaffected by the solar wind. Instead, these auroras are caused by a combination of particles ejected from Saturn's moons and Saturn's magnetic rapid rotation rate. But these non-solar originating auroras are not completely understood yet.